Hello students, so this is lecture number 2 of the chapter electric charge and electric field. Okay, so first lecture was all about introduction to electric charge, right? Like in the previous video we discussed about what is electric charge, types of electric charge, what are the different units of electric charge, right? And we had also seen that the removal of electron from a body will make the body positively charged, right? So now we will discuss about the transfer of mass. What happens to the mass of the body when you are charging a body by any means, right? Okay, see suppose there is a body having mass m. Clear? Already in the previous video we had discussed about the definition of charge. It is an property of the matter. That means charge cannot exist without mass. This is what we had seen in the last video. See, this is a body of mass m. Let's say it is having a charge q, or finally let us say it's a neutral body. Neutral body is having a mass m. Suppose you are rubbing this body with any another body. That means you are charging this body with the help of friction. Right? Okay. There is a neutral body A. Suppose I am rubbing this body with any another body B. Right? Body A, which is neutral, is being rubbed with another body B. Okay. Suppose let us say A body acquires positive charge. That means by rubbing body A, some electrons of A are being transferred to B. So body B, it must have gained electrons, so it will be negatively charged. Clear? You are getting the point? Now, body A has lost some electrons, or rather we'll say that body A has transferred few electrons to body B. Now we know that mass of one electron is 9.1 into 10 raised to minus 31 kilogram. Let us say that n number of electrons are being transferred from body A to B. So, the positively charged body has lost n number of electrons. When a body is losing one electron, its mass decreases by this amount. So, body A has lost n number of electrons. So, of course, positively charged body, its mass will decrease. Because electrons are being transferred from A to B. One electron means 9.1 into 10 raised to minus 31 kilogram, mass will be reduced. So n number of electrons are being transferred. So mass of positively charged body will decrease. These electrons are gained by body B. So its mass will increase. So now mass of body B will be greater than mass of neutral body, and mass of body A will be less than neutral body. This simply means that mass of positively charged body decreases if you are performing any process, or if you are charging the body by friction or by any means. It's not that you have to charge the body by friction only. Clear? And mass of negatively charged, it will increase. Clear? Right? Okay. So this was about the change in the mass when a body is being rubbed with the help of another body. Fine. Now, see, Suppose if this is a question given to you, it's very easy. What happens when a body is rubbed with another body? What happens to the mass of the body? What happens to the mass when a body is rubbed with another body, right? Options are: will increase, will decrease, remain same, or may increase, may decrease. Okay, see, the question is, what happens to the mass of a body when it is rubbed with another body? See, in the question it is not specified that you are talking about which body. You are talking about positive body, positively charged body, or you are talking about negatively charged body. We had seen that when a body is positively charged, its mass will decrease, but when a body is negatively charged, its mass will increase. You don't know the type of the body, whether it is positively charged or negatively charged. So your answer will be, it may increase or it may decrease. We don't know the type of the body, whether it is positively charged or whether it is negatively charged. Clear? So your answer will be may increase or may decrease. The question can come in this way also: what happens to the weight of the body when it is rubbed with another body? So your answer will remain the same. Or what happens to the positively charged body when it is rubbed with another body? Then your answer will decrease, because positively charged body will lose mass, negative will gain some mass. Clear? Now, charge, electric charge is measured, or rather we'll say the presence of electric charge is detected by the instrument known as gold leaf electroscope. Electroscope is a device which is used to detect the presence of electric charge. This is a device which is used to detect the presence of electric charge. Fine. Okay, now we will go for quantization of charge. Quantization of charge. See, and we'll also know about quarks. Okay. Quantization of charge. What do you mean by quantization? Quantization means not continuous. Not continuous. This is an interesting topic about quantization of charge. Quantization means not continuous. It cannot have each and every values. It will have only fixed values. See, we'll understand this by taking an example. Suppose there are two bodies, body A, body B. Say body A was first electrically neutral. Body A was neutral. Now, by any process, suppose A is losing electron, and these electrons are being transferred to body B. Or let us say that when body B is rubbed with body A body will lose electron and B is gaining electron. So, what will be the charge that appears on body A and appears on body B? Suppose A is losing one electron, suppose. Or rather we'll say that if one electron is being transferred from A to B, then A will have positive 1e charge because it has lost one electron, right? Body B will have negative charge. Both were electrically neutral before the process. So after the process also they are neutral. Add both these charges, you will get neutral. Suppose two electrons are being transferred from A to B. So A will gain plus 2e charge, minus 2e electron. B is gaining electron, so it will have negative charge. A is losing electron, so it will have positive charge. Again they are neutral. Now if I am saying that A is losing half the electron, 1/4 of electron, 3/4 of electron, is it possible? No, this is not possible, right? That means charge on the body A or body B will never have each and every value. It will only have a fixed amount of value. That is why it is known as quantization of charge. That means we can never say that body A has lost 3.5 electron. So A will have this charge 3.5 E. No, we cannot say this, because it is not possible that body A will lose 3.5 electron, or it will lose 3/4 of electron, 1/4 of electron. These values are not possible. So that means charge on the body A or charge on the body B will never have these values. 3.5, 3.6, these are the values which A or B can never possess, right? So the next possible value for A will be +3, -3, +4, +5, because electrons as an whole will be transferred from A to B, right? We cannot divide the electron and we can say that okay, this part of the electron is being transferred. No, it is not possible. So charge on the body, whether you are talking about A or whether you are talking about B, this is n times of E, where n is an integral multiple of E, or you can say n represents the number of electrons transferred. So n can have the value 1, 2, 3, 4, 5, 6, 7, dot, dot, dot. It can never have the value 1.2, 1.4, 1.6, 1.78. These are the values which A or B can never have. Here, this is what is quantization of charge. That means charge on the body will only have fixed values. It will not have continuous and each and every value. That is why the topic name is given as quantization of charge. Clear? But the another thing about quantization is it clear? That means as a whole, charge on the body can be 1E, that is 1.6 into 10 raised to minus 19, 2E, that is 2 into 1.6 into 10 raised to minus 19, that is 3.2 into 10 raised to minus 19, or 3E, 4.8 into 10 raised to minus 19. So these are the values which a body can have, and these are the values of charge which a body can have. Clear? But many a times we are neglecting this quantization of charge and we are treating charge as continuous, right? Like suppose the question it is given that a charge of 2 coulomb is flowing or a charge of 2.4 coulomb, right? That means quantization of charge is being avoided, is being neglected, and charges are considered as continuous. So we are dealing with all the values of charges, right? One example to understand that why quantization of charge is neglected and why we are considering charge as continuous value. That is why we are taking the values of charge as continuous, right? See, suppose I want to establish a charge of say 1 microcoulomb on the body or on the surface of the body A. 1 microcoulomb of charge I want on the body A. For this, how many electrons should be transferred from one body to another? Because as I earlier said that you cannot deposit positive charge on the body. No, you just have to remove electrons in order to gain positive charge. So with the help of quantization, Q is equals to NE. So 10 raised to minus 6 equals to N into 1.6 into 10 raised to minus 19. So N is equals to 10 raised to minus 6 upon 1.6 into 10 raised to minus 19. Forget about the value, but let us compare the power. It will be nearly 10 raised to 13, right? Or 10 raised to 12, because if I think this will be 0.625, I'm not exactly sure, 0.625, right? So this many number of electrons are to be transferred or are to be removed from this body to say any another body in order to establish a charge of just 1 microcoulomb. In order to have a charge of 1 microcoulomb, in order to establish a charge of 1 microcoulomb, this many electrons are to be removed, which are very large in number, right? That means 1, 2, 3, 4, that is, this is how we'll have 10 raised to 13 electrons. which are very large in number, so we cannot have discrete values. We'll consider charge as continuous values. That is why quantization of charge is neglected. I'll give you one more example. See, I am just drawing the dots, but they are very close to each other, and they are very large in number. I am drawing the dots, right, which are very close to each other and very large in number. But if I am asking any one of you sitting back, then you will take this, or you will see this as a line. This is exactly what is quantization of charge. See, they are not actually continuous. I am drawing the dots, 1, 2nd, 3rd, that means it is not continuous. But since they are very large in number, you will treat them as continuous. You will see these dots as line. This is what is quantization all about. Right? Actually charges are always quantized. But just in order to establish a charge of 1 microcoulomb, 10 raised to 13 electrons need to be transferred from that body, which are very large in number. So we are not able to see the charge as quantized charge, but we will say that charges are continuous. This is why quantization of charge is neglected at macroscopic level, at high level. Here, these are dots. That is, actually this is not continuous, but when I am asking you, you will see this as a line. That means you will treat this as continuous, just because they are very nearer and they are very large in number. Exactly the same concept goes here. Right? Now, protons and neutrons are made up of more fundamental particles known as quarks. Protons and neutrons are made up of more fundamental particles known as quarks. Combination or addition of quarks will form proton and neutron. There are 6 types of quarks: up quark, down quark, charm, strange, top, bottom. These are all the different types of quarks, 6 types of quark. Quarks don't have independent existence, they will always be in pair. Like if we take an example of proton, inside the proton there are 2 quarks, up quark, and one is down quark. This is how they exist, up quark and down quark. Charge on up quark is 2 by 3e, and down quark will have a charge minus 1 by 3e. Proton is made up of 2 up and 1 down, so u plus up plus down. So that is 2 by 3e plus 2 by 3e minus 1 by 3e. 4e by 3 minus 1e by 3e by 3 will have the charge of proton. Clear? This is how charge of proton is done. So proton is made up of more fundamental particles known as quarks. Even neutron, neutron is made up of 1 up, 2 down, up quark, down, down, up, down, down, right? Add this, up plus down, 2 by 3e minus 1 by 3e minus 1 by 3e, neutral, will be 0. That is why neutron is neutral. Electrons are not made up of quarks, they are made up of more fundamental particles known as leptons. Fine. So in the next video now we will discuss about the charging methods, how to charge a body with the help of induction, friction, conduction, and we will solve few questions based on these methods.